Hello everyone, and welcome back. So in this lesson, we are going to be talking about, what are some of the differences between processing and p5.js, and in particular from the perspective of somebody who's learned already processing and then is coming to p5 with just a fresh set of eyes with no experience. So this is going to be a little bit of a crash course in p5.js, and we're going to focus on the things that are really different between the two languages, just so that you can kind of hit the ground running and be able to interpret some of the examples that we're going to be doing throughout the semester. You're not going to learn everything you need to learn about JavaScript and P5 in this video, but you'll know enough that you'll be able to make your way around and follow the examples as the semester unfolds. And yeah, so let's get right into it. Okay. All right. So this is where we left off in the previous video. We had started working on this RTA842 blank program. This is what it looked like, just a simple circle following the mouse. So before we actually get right into it, we're going to make a couple of more additions to this blank program, and then we're going to start to unpack some of the differences between this P5 sketch and maybe some of the processing sketches you might be used to. If you've already done P5, let's say in the course I taught last semester, then this can be a bit of a useful little refresh to kind of get back in the rhythm of things as well. So the first thing I'll do here is we're going to add another function called window resized. And this is going to allow us to basically like resize the canvas whenever we draw this middle section here, whenever our window gets resized. So by default, let me just comment this out. If you'll remember, if I drag this here and change the size of my browser window, right? This is an embedded browser window here. The size of this frame, the size of my sketch doesn't actually update automatically. So the window width and window height variable may no longer correspond to the width and height of my sketch. So with resize canvas, we can simply, whenever the window gets resized, so this is an event that p5.js has. Yes, good old semicolon. Whenever the window gets resized, the canvas should, resized with a D, the canvas should get resized as well. Okay. So this is kind of more of a little convenience cosmetic thing. If you move your canvas around, it's annoying having this black or white space here kind of left over. So I like to have that part of the template. And then the other thing I like to do is just separate these functions with some comments, just so that they're visually like it's easy to distinguish between them. This is just a habit that I have. You don't have to do this, but I'll bake that into the template from, so this setup here runs once in the beginning, is the same thing as with Java processing. Once when the window is resized. This is new from, Java processing, but we kind of understand the concept of events from processing, things like mouse pressed or mouse moved. This is a kind of event which will only run when this thing happens, right? When the window is resized, this code runs. And then draw is our main program loop. Okay. So with these comment lines, this is just, like I said, something I like to do. It gives me some visual cues that these are like different sections of my code. And I like to do that for other functions as I add them down the road. So this program here can become our main template. We're going to get rid of these two lines because really put code here. And then put init code here. We're going to just make our blank sketch be an actual blank canvas, so that every time we take it and create a new sketch from it, we don't have to constantly delete these lines. Okay. So the way this works in Glitch is going to be using the remix feature. Okay. So if we were using, for example, the P5 web editor or maybe the processing editor, whenever we made a new sketch or a new program, we would simply create a new window and then we would start there from scratch. Same thing in the P5 web editor. On Glitch, what we can do is we can take a project and we can remix it, or basically clone it and make it our own. So the way we're going to work this semester is I'm going to share with you the link to this RTA842 blank project. I'm not going to touch this project moving forward. This is going to serve as our starting template that we're going to use to be making all of our exercises and demos and examples. We might create some new templates as we go forward if we add some features. So we'll probably have a different template once we dive into Node.js and server-side programming. But for now, this is going to be our basic static, p5.js web page template. So from this program here, if I wanted to clone it and create a new version of it, what I would need to do is simply click the remix button. And so this is one of the core features of Glitch. You can take anyone's project that you find on Glitch, and you can simply remix it, clone it, and make it your own. So this creates a fork from the original project, right? See how it's identical now, except it's been given a new randomly generated name. Okay, so let's rename this. We're going to call this example RTA842 diff or differences. Okay, this is going to be about the differences between P5 and processing. So now I've taken the blank page and I've used it to kind of spawn a brand new sketch. So every time you want to create a new program this semester, you can always go back to my template, remix it, and then you have a blank sketch to work from. Okay. All right. So the goal of this lesson is going to be, like I said, kind of go over, for those of you who've learned processing and not P5, just go over some of the basic things to be aware of that are significantly different once you dive into writing some basic sketches. The first, elephant in the room, giant difference is that they're written in different programming languages. And even though they share the JavaScript sounds like it's related to Java in its name. It's just very unfortunate naming. They in fact have nothing to do with each other whatsoever. The only thing they have in common is that they're both programming languages that kind of share some of the same basic concepts of programming, things like functions, classes, conditional statements, right? If statements, for loops. So these ideas, variables, arrays, these ideas are shared between the two languages, but the syntax to program them is going to be a little bit different. JavaScript is also a fairly lax and flexible language. It's very deep. We're not going to get super advanced with JavaScript in this course. We're going to stick mostly to the kinds of JavaScript that we can do within p5.js. So we're not going to stray too far from the processing kind of philosophy and recipe. So a lot of the ideas are going to be very familiar to you already. So one of the first differences that we can point out, so even though the structure of a P5 sketch is similar, right? We have a setup section, which runs once in the beginning. Then we have a draw section, which is going to be our program loop or our animation loop. You may have noticed here the keyword function. So in processing, in Java, we would use a void here. So functions would have a return type, and we would indicate it with the keyword over here. A void, which meant no return type, or some other functions may have had an int or a float return types. In JavaScript, there's no such thing. Everything is just a function. Functions can return something or not, but they no longer need to have a return type. And that's because in JavaScript also things don't really have kind of hard enforced types. So in Java, we had to worry about the type of data that we were putting into our variables, for example. We had to worry about, is it an int or a float or what kind of object? JavaScript is very flexible. They're just going to say, whatever, you can put anything into anything. Functions can return any types of values. So it's very lax. Okay, this has pros and cons. Okay, because you can with Java it sort of holds your hand a little bit and forces you to think about what kind of information goes where. With JavaScript, you have to just be aware when you're programming what type of data you're going to put in which places. It's not going to stop you from trying to fit a square peg into a round hole, for example. So more on that later when we talk about variables and how types are no longer that important in JavaScript. So the first big difference is the void keyword is gone. It's been replaced by the keyword function. So a function is the same idea as in Java. It's a functional block of code, right? That's delimited by the curly brackets. So everything that's between the curly brackets is the setup function. It's indicated with some parentheses here that it's a function, and these functions have no parameters. Okay? So this is the same thing as with Java. The only difference is the keyword that goes right in front. Second difference you may have noticed, we no longer have a size, right? In Java processing, we would use the size command, and we would give it either a size, right? Usually we would start with a fixed size because we would end up with a window from processing when we hit the play button. So we did not necessarily have access to the display width and height. So this aspect of processing is gone now in p5.js. It's been replaced by the createCanvas function. So canvas comes from the fact that when we draw things in processing, we are using an HTML element called the canvas. P5 is not the only library that can do some drawing into the browser. There's lots of other ways you can, if you wanted to roll up your sleeves, you could write HTML and JavaScript that manipulates this canvas element directly that allows you to draw shapes and lines and text and images. What p5.js does is it packages all of this in a very kind of friendly interface, in a familiar interface coming from processing. You're going to recognize a lot of the same functions and commands that you are used to. So you don't have to learn a whole new paradigm. You don't have to learn the HTML canvas in order to get started with p5, which is wonderful. So createCanvas using the window width and the window height basically takes the space we have available and makes it as big as you can. You could, of course, if you wanted to, specify numbers here to make a tiny little, let's set a background, not white. The background of our HTML page is white, as you'll recall. So we could set a smaller canvas if we wanted to, but what's the point? Unless you really want to keep it small, I encourage you to just use the room you have at your disposal and just make it fill the window. Okay? So that's the second other big difference. The size function is gone. Okay? All right. So let's talk briefly about variables. Okay? So the built-in variables that we had access to in processing are mostly all back. So if you'll recall, in processing, we would do things like ellipse, mouse X, mouse Y. So we have access to the same built-in variables. We also have access to width and height once the canvas has been defined, right? So I could create an ellipse that is using a quarter of the size of the canvas or half, right? So we have access to the same built-in variables if we want to. Okay? Mouse X, mouse Y, and then of course the keyboard related ones and so forth. So these are still around. The other thing we can do in p5, of course, is define our own variables. And this is very different than from Java. And it's in fact a lot simpler. Now, we talked about before, there is no longer data types in JavaScript, or at least not explicit ones. So if we want to create a variable in p5, we use the keyword let. So we could create a variable, for example, called circle size. Okay? And notice this is something I like to do. I like to capitalize when I have two words here. I like to put the second one with a capital letter for readability. You'll see a lot of programmers do that. So this allows me to create, so the keyword let lets me define a variable called circle size, and then I'm assigning a value to it, right, of 100. And then having done this, circle size, I can now use this as a variable into my code. Okay? So in processing Java, we would have had to write int circle size, right? Or maybe float if we wanted a decimal point value. In JavaScript, we don't have to worry about this anymore. We can just write, we could write 75.2 here, and it would still be fine. Okay, so we can put anything into circle size. Okay, the advantage of that is now we don't have to worry about type anymore ahead of time. Do I need an int? Do I need a float? It's just a variable. Okay, so it could be, it can just be a number. The downside is that we can put anything in there, right? So I could put a string in there, and this obviously is not going to work, okay? So in Java processing, it would be very hard to make this mistake, but in this case, I mean, this is a stupid example, but you can literally put anything into any variables, but then once you try to use it for something, you have to put, use the right information in the right spot. So circle or ellipse expects a number here, and now nothing happens. So going back to the previous video, what to do when things, nothing happens and something should happen, you open the console. Right, so we're going to open the developer tools here just to see what kind of error we are getting. All right, so now we're getting an error that says ellipse, right, was expecting number for the third parameter, received string instead. Not cool, not cool. So we're going to go and put a number back in. Okay. So you have more flexibility with your variables, but the downside of that, right, is that you have to be a little bit more careful about, now that you have all this newly found freedom, what you do with it. So just like in Java also, the idea of variable scope applies. So this circle size here is a global variable. So you'll recall global variables are these variables that are available everywhere throughout your program. So they are, permanent. You can accumulate in them, like over time, this circle size could grow. This is the same syntax, right, as before. Ooh, this is getting huge. So global variables can do that. You can accumulate stuff. If you define a variable inside a block of code, which you can do, it becomes a local variable, which means its visibility is only here and its lifespan is limited to this particular block of code. So now I'm getting an error down here, circle size not defined. That's because circle size is now local. I've moved it into setup. Okay. So let's put it back as a global. So this same idea applies. This was the same in processing. Just as a little, let's get rid of that. Just as a little aside, also, when it comes to variables, undoubtedly, as you learn more about P5, you're going to go out and look at some code, hopefully look at some examples, what other people are doing with it, and you're going to notice there's a few ways that people declare variables in JavaScript. One is using the keyword let, which is, I guess you could call it the more modern way. We're going to use let for everything this semester. This is we're not going to go into the details of the differences between let and var because they become like very specific. But the other keyword you may run into is var, and that one works as well. Okay, this var is short for variable, and for a while in JavaScript, that's all you had was the keyword var. Okay, so if you see this in the code somewhere, somebody's program, just think of it as these two for now as interchangeable. Okay, they have some subtle differences between them that we don't really need to get into for this course. So both of them allow you to create variables. We're going to use let out of habit because, like I said, it's a bit more modern than var, but this works as well. Or you might run into some older examples, older programs, they're going to use the keyword var. The third way you can define a variable in JavaScript or P5 is using the keyword const for constant. A constant, as you may guess, is a variable which you're not allowed to change. So I can declare a constant, like circle size, okay? But if I try to be sneaky, that's another way we can accumulate, right? If I try to be sneaky, I try to change the value of circle size to anything else, okay? It's going to give me an error. It's going to say assignment to constant variable. No good. Okay, you can't do that. So constants are useful if you want to make sure some variables in your code will never change. This is useful in bigger projects, right? If for the scope of things we're doing in this class, constants are, we don't need to worry about them so much. They do have implications in terms of performance, things like that, where the compiler can make all kinds of assumptions about your program if it knows this variable is never going to change ever. So you might run into this if you look at some of these else's programs and they define things using this const keyword for constant. It just means they are kind of immutable variables. They're constant. They can never change once they've been created. Of course, we are going to use let for the most part. Now see, I made it a regular variable. It means it can change. Okay. We're going to use let. Even sometimes we're going to define constants that don't change. We're not going to use the const keyword. I'm not going to get into that level of nitty gritty, but it's good to be aware of it. But like I said, you should be reading code. You should be out there looking at examples, and you're going to run into these and you're going to wonder, why are they using these different keywords? And now you'll know. Okay. All right, so variables are quite different in JavaScript than Java, but fundamentally it's the same idea, right? Whenever you want your program to remember some kind of information, accumulate something over time, whenever you want to represent quantities in your program, replace them with words that are much better than hard-coded numbers, we're going to turn to variables the same way we were doing in Java. Small little aside here. I've kind of used it in the previous video, and you may have noticed, but one of my favorite things about p5.js is that it has a circle function. Instead of only having an ellipse, circle, right, is what we draw most of the time. Can't remember the last time I actually used ellipse to draw something else other than a circle. So with the circle function, we can pass in just a diameter, a single value. Okay, so this is nice. We're going to be using circle quite a bit. And this is a kind of a good segue into sort of looking at getting a bit of an overview of the different commands that are available in P5. A lot of them are similar to processing because processing was used as the template, so to speak, and the inspiration. So they tried to follow a similar thought process in terms of designing the library, but it's not a one-to-one correspondence. So it really they've strayed away from processing where it made sense. So just like in processing Java, the reference page is still your best friend. So if you go to the p5.js website and click on reference, you will get, just like in processing, just a list of all the different functions or commands that are available, all the different keywords, the different shapes. So we can see we have circle. Just like with processing, there are very good examples for all of them that are documented, telling you exactly what everything is. So as you navigate this new environment, just keep falling back to the reference to figure out what is still there, what's different. And you'll see a lot of the things are the same. A lot of things are similar, and some things are also a little bit different. Okay. So on the surface, though, a lot of the things you were doing in processing is going to translate, at least when it comes to the basic usage, drawing primitives, the basic math functions, and so forth. One area that has a fair bit of difference, though, is when it comes to colors. So in processing, we would, we have the same color mode. We would specify colors primarily using numbers, right? Either numbers for gray values or RGB values for red, green, and blue, or HSB values, right, for hue, saturation, and brightness. But with P5, we have a little bit of extra flexibility when it comes to designating colors. We can use color names, which is great. These are the standard HTML color names. So we could Google this. This is the first result I got. This is a list of all the 140 HTML color names. Some of them are obvious, right, like black and blue and so forth. We could guess them, but there's some, more esoteric colors like coral or dark orchid. So you can refer to these names in your programs. For example, if I wanted to have a coral background, I could ask for that. It gives me the coral background. So you can define color names as strings. Of course, you can still use, the good old RGB, right? This would be red. So we have a little bit more flexibility in terms of the colors because we are now living inside the HTML browser space. And we also can use hexadecimal style color names for RGB colors, right? So there's a few different notations. The other ones we don't necessarily have to get into. So there's a bit more flexibility when it comes to defining colors in P5. And we're going to take advantage of that. Instead of using 0 and 255 for black and white, we're going to use the color names whenever appropriate, right? So here, if I want to have a black background and a black fill and a white stroke, right? I can still do the same kinds of things I would do in processing, just now I can use color names if I want to as strings. Okay. You may also notice in p5.js, strings can be single quotes. They can also be double quotes. It doesn't matter as long as you're consistent which one you use. So you can use one or the other. Both of these things are strings. Okay, so if you start with a double quote and you end with a double quote, it's a string. If you start with a single quote and with a single quote is also a string. So both of these are fine. Okay. All right. Okay. So let's do one more little example, and then all of the other important differences we are going to unpack as the semester goes on, and as we do more and more intricate examples with our tutorial series. So the last thing I want to touch on in terms of the differences between P5 and processing are arrays. So arrays work pretty differently in JavaScript than they do in Java. So let's say we're going to create here an array, and positions. Okay. So the syntax for defining arrays is a little bit different. So in Java, you may remember that when you created an array, you had to define first of all, the type, right? So we don't have types anymore. You also had to specify the size right away. So arrays had fixed size unless you use this object called an array list. Well, in JavaScript, just the basic array is closer to the Java array list, which means when we work with arrays, we're going to be able to do things like this. We're going to define arrays as just an empty array over here. And then we'll have a little bit more flexibility in terms of like how we get to manipulate this array. So we're still going to use the idea that, we access elements using an index. So for example, I could do this, and I could go at index 0, even though I haven't set a size, and I could put a value into the array. Okay, so that would work. Or I could just kind of jump ahead and even go at like index 10, even though I haven't set a size. Now this would kind of expand the array to 10 positions or 11 positions, and then at the last index value, put the number 100. Okay. So I could do that. Or we can also dynamically just add at the end of the array. So in Java, we had the array list object that allowed us to kind of start with an empty array and then just add to it over time. We can do the same in JavaScript. So this positions array, for example, has a push function that we could use to add something to the end of the array. So this would allow us to kind of add the number 100 at the end of the array. So let's develop here a quick little example that's going to basically allow us to say, like, every time I click somewhere into my into the canvas, right? Well, actually, no, we're going to record. Let's not do that. We're going to record a trail of where the mouse has been, and then we're going to redraw that trail over time. Okay, so I'm going to need some way of recording the mouse position using the array, and then that'll make a little bit more sense. Okay, so let's create an array here called positions x, or it's a bit long, so I'm going to just call it POS x and y. Okay, so we're going to make two arrays here. I don't have to do anything else and just declare them. Okay. And what we're going to do is over time, we're going to add the mouse position to these arrays. So we'll say POS.push mouse x, and then POSY.push mouse y. Okay, so we're going to record the mouse coordinates. And then instead of drawing a single circle, right, we're going to use a for loop. Now the for loop is going to work the same way as it did in Java processing. The only difference is when we define the counter, the variable we're going to count with, we're going to use let instead of int. Okay, so we'll say create a counter called I, right? As long as I is less than the size of our array, we're going to repeat. So the for loop structure is the same in JavaScript. And then what we'll do inside of the for loop here is we're going to do a circle, but instead of using mouse x and mouse y, we're going to say position x bracket I, position y bracket I. And then we can put down circle size as this size of the circle. So let's recap here. So this is just an example to show you how arrays work a little bit differently in JavaScript, right? So when we define them, we don't need to specify a size. Oftentimes we're going to use them in that way. We're going to just push values at the end of the array, right? We're going to keep expanding. And then we can iterate through the array using the same type of syntax we used in Java. The for loop idea is identical, right? If you'll recall, we define a counter that we're going to use to count with. Then we set a condition, right, that the loop is going to repeat until this condition, right? As long as this condition is true, we keep repeating. And at every step of the way, we increase the counter by 1. And then we can access elements of the array much in the same way using the brackets and the index notation. And similarly, if statements are going to work the same way as they did in Java. For example, we could say if our arrays get too big, let's say maybe more than 25 values, okay, we could start removing old values from the array. So the arrays in JavaScript are a lot more malleable and a lot more like array lists in Java. So if we want to remove something from an array, the command to do that is called splice. And we'll explore some of these commands in future examples as well. So splice says, which index do you want to splice from, right? So we're going to go to index 0, so the oldest value in the array. And then it asks you how many values do you want to remove. So we're going to remove one element starting at index 0. Okay. And we should do the same thing with the y values as well. So now we're only storing 25 mouse coordinates, right? As soon as the position X array gets too large, right, we remove older values using splice. So these arrays are a lot more malleable. And because the topic of this course is going to be working with data, you can expect we're going to do a whole lot more array manipulation. So we're going to get pretty good at this, but this is just some initial recap and also pointing out some of the biggest difference coming from, from Java and processing as a background. Okay. So we're going to leave it at that for this week's examples. There's not going to be any particular code exercise for this week, other than I would encourage you to just go ahead, remix, try remixing our RTA842 blank sketch and just write a little program, just make a little doodle, could be anything, just to get familiar with, p5 and what are some of the things you can do. You'll basically be able to create very similar things that you could in processing. Just go back to the reference if you're not sure about what some of the colors are, the commands are, maybe you've forgotten them. You can also take a look at some of the examples. So just like in processing, p5.js has a whole bunch of interesting examples. Some of them are ports from the processing examples. Some of them are brand new ones. So take a look at some of the examples. Just poke around, get comfortable. I would say at least remix the blank sketch once to modify it and make it your own. This is not something I'll ask you to submit, but it would be a good idea to do that. And yeah, and then we'll take it from there. In the future weeks in the semester, we'll do lots and lots of examples using P5 and working with data. And as usual, we'll kind of explain things over and over as we go along. So you'll be able to get up to speed fairly quickly. All right, I'll see you in next week's videos.